Distribution of the scores on a certain exam is normal with a mean of 50 and a standard deviation of 10. Sketch the curve and label. So you know that the mean is going to be in the middle, which is a 50, and it's going to be spaced out in units of 10. And the only one that has that is B. What's the probability that the score will be greater than 70? So using that same empirical rule here. So one deviation is going to be 68% of the data. So 2% would be at 95. Two deviations would be at 95. So that means 5% here. So that means that 95% of the data is going to be within two deviations. That means you have 2.5 on this side and 2.5 on that side. So it should be 2.5. Which one corresponds to the graph? B. Use estimator for the population mean is the sample mean. A study of all students at a certain college showed a mean age of 20.3 and a standard deviation of 1.8. Okay. Numbers of parameters are for all students, not a sample. Choose correct symbols. So they're showing for the population mean and for the population standard deviation. A survey of 100 random full-time students at Lush University showed that the mean was 10.4 and deviation was 1.5. The statistics, because they represent a sample of students, not all students. X bar for the mean and the S for the standard deviation, sample standard deviation. Assume that the average length of all phone conversations was 4.5 minutes, and deviation was 4.9 minutes. Well, it'll be right skewed because mostly small, but there'll be a few very large. There'll be a few very large values, but it'll mostly be small numbers. So you have very few people that are talking for a long period of time. Most of them won't talk as long. Suppose we sample 100 phone calls and repeat it 1,000 times. What would the approximate mean be? The approximate mean would be the sample will approach the population at 4.5. Sample mean approach population mean 4.5. So what would the standard deviation be? As you increase the sample size, the error is going to go down. In this case here, we got it down by 100 yeah, to 4.9 to 0.49. So when you look at one like this, you can see, for example, here, there's our mean. So here we have 4.6 standard deviation divided by 100. You get 0.46 there for the standard error. That's where that comes from. Several times during the year, an organization takes random samples from the population on one such survey based on a several thousand sample random selected households estimates the mean out retirement income to be $21,201. So it's supposed to be a histogram, but histogram display the population distribution, distribution of the sample, or the sample distribution. It'll be histogram would display a distribution of the samples, how the samples were distributed. Okay. A human resource manager for a large company takes a random sample of 50 employees. She calculates the mean time they were employed. She records the value, then repeats the process. Takes another sample of 50. After she's done this 1,000 times, she makes a histogram. Does the histogram display the population distribution or sample distribution of the means? It shows the sampling distribution of the means, which is different from before. So it's supposed to be a histogram of the incomes in the sample. They represent the distribution of that sample for number 917. But this one here, this makes histogram of the mean employment times, plural, so to represent the sample distributed sampling of the means. The average income in the state was 50,000. Deviation, standard deviation was 21,000, and it was right skewed. Okay. We should respect for the sample mean, 50,000. Sample mean is an unbiased estimator of the population mean. What is the standard error? So we have our standard deviation and we have our n. There, standard deviation and our n, so we can find the standard error. It's 1400 there. So that's how you find the standard error. The spread of the distribution of the sample mean is much smaller than the spread of the population. As the sample sizes increase, the spread of the sample means decreases. How does one calculate the standard error of the sample means? Divide the population standard deviation by the square root of the sample size.